This video only includes reality. Neuroplasticity is the ability of our brain and nervous system to change and adapt in response to experiences. It allows us to think differently, learn new things, and adapt to life. Babies are born with a highly connected nervous system that is designed to learn. As they grow, some connections become stronger while others disappear. This developmental plasticity happens from 0 to 25 years of age and involves the elimination of connections that do not serve our goals. During this period, both positive and negative experiences can have a permanent impact on our brains. However, after the age of 25, the brain becomes less plastic, and making changes to the nervous system requires different processes. While some areas of the brain are non-plastic and control essential functions like heartbeat and breathing, many other areas can be changed. The ability to learn through passive experience is especially important during childhood, teenage, and young adulthood. Overall, understanding the different forms of neuroplasticity and their age-dependent effects is crucial for accessing and benefit from the brain's adaptive potential. Ramon E. Cajal, one of the greatest neuroscientists of all time, wrote a book. His words go something like this: if people want to change their nervous system, they can become sculptors of their own nervous system and change it as they wish. That sounds very nice. Who wouldn't want to change their nervous system? But what these words don't really address is how to do it, which we will talk about in this chapter. But first, I want to say again that we are born with our nervous system wired in such a way that it cannot do anything properly. From birth to the age of 25, these connections are basically eliminating the connections that don't have a function and strengthening the ones that do, according to our experience. After the age of 25, if we want to change these connections, we have to activate very specific processes. Many of you may have read in the press that the human brain is adding new neurons. They say that when you run or exercise, the brain adds new neurons. The reality is different and even worse. After the age of 14 or 15, the human brain and nervous system produces very few, if any, new nerve cells. In general, we are born with nerves that we will use for life, and we lose nerves as we age. But the good news is that neural circuits have mechanisms for creating new functions other than adding new nerve cells. Nerve cells can gain new cognitive abilities by making new connections. This mechanism, using synapses between nerve cells, can make new connections as well as break existing connections. The breaking of connections is important because this process is also necessary to recover from painful traumatic experiences. So even though we can't make new nerve cells, we can use our nervous system. But we have to create the conditions in the brain for that to happen. In early childhood, there is a lot of space between neurons, and neurons are literally free to move. They can move around and try out new connections and easily strengthen or break them. As we age, these gaps become connections and glue between glial cells. In our brain, we walk around with a map of the world. We have a representation of the world that we can see, hear, smell, touch, our feelings, who are trustworthy people, who are untrustworthy people, etc. In the 1970s and 80s, scientists David Hubel and Torsten Wiesel conducted experiments at Johns Hopkins and Harvard Medical School to study brain activity and visual perception. They discovered that the visual brain rewires itself based on the visual information it receives. Other researchers, such as Greg Reckenzone and Mike Merzenich, found that sensory systems in the brain can also become intertwined, leading to a lack of distinction between separate movements or sensations. The brain is shown to be a personalized map of the external world, and changing the nervous system requires thinking about what you want to achieve and letting go of certain connections. Hubel and Wiesel won the Nobel Prize for their work. It was thought that there was a critical period during development when changes in the visual system could happen, but later research showed that the adult brain can also change under certain conditions. Overall, attention is critical in helping to brain plasticity and change. In a study performed by Merzenich and his team, subjects were asked to press a crowbar when they felt ridges on a spinning drum move closer or further apart. The experiment was designed to understand how attention affects the brain's ability to detect change. The results showed that the more attention the subjects paid to the task, the faster the brain was able to detect changes in the finger representation area. This neuroplasticity depended on two neurochemicals, epinephrine, or adrenaline, which is released when we are alert and focused, and acetylcholine, which amplifies the signals associated with focused attention. In addition, acetylcholine, which is secreted in the forebrain along with epinephrine, can lead to changes in the brain. Experiments stimulating these brain regions with electrodes have confirmed that attention can trigger neuroplasticity, allowing for significant learning experiences. This discovery is now recognized as one of the foundations of the nervous system. To put the science into practice and achieve attention and focus, it is important to prioritize getting enough sleep. There are several strategies that can be used to increase attention, such as creating accountability or using emotions like fear and shame as motivation. Epinephrine, a chemical in the brain, is released based on emotions such as love, hate, or fear, and plays a role in activating attention. With the prevalence of distractions such as smartphones, it is necessary to learn to focus deeply and develop mechanisms for mental focus. Visual focus can affect mental focus, and training the eyes to focus on small areas activates specific areas of the brain associated with information gathering. Also, giving full attention to learning something, even if it causes a sense of distress or anxiety, is crucial because it can improve focus. The advice given is to practice focusing on something for longer periods of time without blinking as often. This can help control focus and improve concentration. While some people may have clinical hyperactivity and require medication and behavioral treatment, many people experience low-level hyperactivity due to habits such as extreme cell phone use. The small screen size of mobile phones makes it easy to focus on them, and features are designed to capture attention. However, too much reliance on visual media such as videos and social media can interfere with the brain's ability to absorb information from reading. It is important to assigning neurochemical resources to tasks that excite or challenge us, rather than passively consuming content that does not strengthen the brain. To improve focus, it is recommended to set aside a specific amount of time, such as 90 minutes, for intense concentration on a task, minimizing distractions such as turning off the internet and physically putting away your cell phone. Neuroplasticity, which supports learning and behavioral change, happens during sleep, so focusing intensely on an activity during the day can strengthen the neural circuits associated with that activity. Sleep is critical for improving brain function because it allows for neuroplasticity, the brain's ability to change and adapt. Both the quality and organization of sleep are important factors in this process. Even if you have a bad night's sleep after learning something, as long as you have a good night's sleep the next night or the night after, the brain can still change. Acetylcholine plays a role in marking synapses that are more likely to change neurochemically and metabolically. However, if you are constantly starved of deep sleep, these changes will not take place. Interestingly, there is a concept called non-sleep deep rest, NSDR, which is a protocol that can help with memory retention. One experiment showed that practicing NSDR for 20 minutes after a challenging task improved learning rates more than just getting a deep night's sleep. Adults can improve their learning by using NSDR protocols and intense concentration for 90 minutes. Multiple sessions of NSDR and deep sleep can be done daily to maximize brain changes and performance. Performance.